Bismillahirrahmanirrahim. Assalamu alaikum students. How are you? Hope that this lecture will find you in best of your health. So we start with exercise 1.6 and question number 3, part A. Now this is a very tricky and logical question. Let me read it out for you. Not included the factor provided find two numbers less than 20 that have HCF of 2. The two numbers, suppose that is number A, that is number B, and the highest common factor of A and B is 2. So my dear students, it is very logical and interesting question also. So what I do here is, first of all, I rule out what can be the numbers for which the HCF of 2 cannot exist. So there are some numbers like 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So 2 cannot be the HCF of any of these numbers. 2 cannot be HCF of any of these numbers. So I have left with some fewer choice now. 2, 4, 6, 8, and then 10 and 12 and 14, 16, 18, and 20 is not included, less than 20. Since it said me, since it is less than 20, so 20 is not included. So what I am left is with 2, 4, 6, 8, 10, 12, 14, 16, and 18. I am left with all the even numbers that are 2, 4, 6, 8, 10, 12, 14, 16, and 18. Since 20 is not included, because we have to find less than 20, and HCF 2. So dear students, I cannot also use 2 because it is not included. Not included the factor provided. Okay. So I start with 4 and 6. 4 and 6. 2 times and 2 3 times. So what are the factors of 4? F4 is equal to 2, 2, and F6 are the factors which 2 and 3. Now my dear students, you see that 2 is the highest common factor. HCF of 2 is equal to 2. So what we come up with the numbers 4 and 6. So we can check it for all the two pairs. So my dear students, let me find another, and that is 6 and 8. I have already found the factors of 6. Now I have to find the factors of 8. 2 4 times 8 and 2 2 times 8. 2 2s are 4 and now what I write here is for F6 the same 2 and 3, and for F8 is equal to 2 2 and 2. Here again you see the students, the factors are, the highest common factor is again 2. So since we have found two numbers less than 20, that is 4 and 6, 6 and 8. So there are many possibilities that can occur in this question. Let's proceed to the next part. Now students, question number 3 part B. Question is the same, but we have to find the pair for which the HCF is 6 and the factor provided should not be 6. Okay. So I have already ruled out, in the previous part, I have ruled out 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Because none of these numbers can get the HCF of 6. This is for confirm. So what I do, I just pick up the even numbers that are 2, 4, 6, 8, 10, 12, 14, 16 and 18. Now there are two methods of doing this question that I find the factors of each and every number, or just I apply my logic towards this. I have to rule out some numbers from here also, and that are the number 6, because the question says that you have to leave the number 6 as well, because he has given the HCF of 6 and we have to see the question also, it is not included. So this is not included. Now the numbers are left which can have the HCF of 6 are 12 and 18. Because unless and until you get 3 in the common factor, you cannot get 6 as an HCF. So we cannot get 3 over here. You can just check it, 2, 4 and 4. 2, 4 and like this. You can check it. You can check it. Very simple. Very simple. I leave it is here. 2 and 7. 2, 8 and rest of the part is 2, 4 and 4, 2. I leave this for me. You see, I haven't got 3 in any of these 3. So I check it for 12 and 18. 12. 2, 6 times, 2, 3 times. I got 3 over here. 18, 2, 9 times, 3 times. So I got 6 over here. So what I write here, F 12, 2, 2 and 3. And for F 18, I write 2, 3 and 3. So I have finally come up with a pair of common factors now. This is a common factor and this is a common factor. When we have a pair of common factor, then we multiply both the factors like this. 2 multiplied 3 and what comes? 6. 2 multiplied by 3 is 6, which is our required answer. There is only one possibility in this question. Now students, question number 4, and what does it says that what is the HCF of two different prime numbers? Give reasons. I have already told you about the prime numbers in my first lecture, as I think. Let us recall that what are the prime numbers. The prime numbers are the numbers which have only two factors and that are 1 and the number itself, that are not divisible by any other number. For example, number 1. Now you see, does the number 1 have two factors? No, it has only one factor. So this is not the prime number. Number 1 is not the prime number. So I just ruled it out. The prime number starts from 2, 3, 5, 7, 11, 13, and so on and so forth. You see, for 2, now this is the only even number in the prime numbers. I told you in my first lecture. Now you can check whether it is divisible by any other number or not. So it has factors of 1 and 2, it has factors of 1 and 3, it has factors of 1 and 5, 1 and 7, 1 and 11, 1 and 13, and so on and so forth. You cannot divide it by 2, you cannot divide it by 3, you cannot divide it by 2, you cannot divide it by 3, you cannot divide it by 5. So these are the numbers which have very exclusive quality, very exclusive quality in them, that they are not divisible by any other number. But the factors are 2, 1 and the number itself. 1 and the number itself. So, what is our question? Coming back to question, what is the HCF of two different prime numbers? So two different prime numbers, this is a two different prime number, this is two different, this is two different, now this is two different and this is two different, and there are hell of the pairs that can be made from the prime numbers. So what we do, when I have to find the HCF of the two prime numbers, I told you in my lecture of HCF, first lecture of HCF, that we directly multiply the two numbers. So when we get two prime numbers, we always multiply to get them the HCF, because now you see that this 6 can be divisible by 2, this 6 can be divisible by 3, and if I get to their factors, these are 2 and these are 3, there is no common factors in between them. So when you don't have any common factors, so what we do? We just multiply them. Simply we just multiply them. Like 7 and 11. You see, 7 and 11, they don't have factors, any other factors which are common. They don't have any common factors. So what we do? We just multiply them. But the outcome, which is 75 in this example, it is divisible by 11, it is divisible by 7. And you can also check it for any other pair, that is 35. If you go for the factors, these are the factors. But these are not, you can't get any common factor between the two. So what we do? We just multiply the both and we get 35. Now 35 is divisible by 7, 35 is divisible by 5. So this is our reason that we don't have any common factor in between the prime numbers. If we have to find the HCF, we don't have any common factor. So we just multiply to get the highest common factor, because highest common factor is divisible by each of the prime number, Now students, there are some questions which are applied questions, and you have to test your skills of finding HCF. So I just read it instead of writing it. Simon has two lengths of ropes. Now he has two lengths of ropes, whatsoever he is. One piece is 72 meters long, and another piece is 90 meters long. Now, what is the question? In fact, I am getting to the soul of the core of the question. Number one piece is how much long? 72 meters long. Now this is 72 meters. And I tell you that always write units. Whenever you get unit in the question, you write unit. Just write the abbreviation of the unit. It is enough. And number two piece is equal to how much it is long? It is 90 meters long. So what he have to do is, he wants to cut both length of rope into the longest piece of equal length possible. How long should the pieces be? Now this is the question straight away heading towards HCF, highest common factor. So we have to find the factors of 72 and factors of 90. Factors of 72. Start from the lowest possible prime number. 36, 18, 9, 3. You can also check it once. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, 24 times 3 is 72. And for 90 meters, again starting from 2, 45. Now 45 is not visible by 2, but it is visible by 3, 15, 3, 5. So what we get here is F 72, 2, 2, 2, 3 and 3. 3 twos and 2 3. And for F90, 1 2, 2 threes and 1 5. So there are some common factors I have come up with are 2, 3, 3. So there are 3 common factors: 2, 3 and again 3. So what we do is, for HCF of the both will be 2 multiplied 3 multiplied 3, and that becomes 3 3s are 9 and 9 2s are 18. Now 18 is a figure that can be the divisor of 90, and that can be divisor of 72 as well. And the answer is 18 meters. What I said you to write the units also, always. Either it is physics or chemistry or mathematics, you have to write the units. When units are given, you write the units. Sometimes what the author do? What does the author do? They write only like this, 72U. Now this U means units. It could be any unit. It could be liters, it could be meters, it could be centimeters, it could be inches, it could be foot, it could be miles, it could be seconds. Question number 6. Anshus has 40 canvases and 100 tubes, and she wants to distribute an equal number of paints and equal number of canvases to each student. And what does she have to do? She have to find the equal numbers that can be distributed of the tubes of paints and tubes of and canvases. So the core of the question is, she has 40 canvases. Miss Sanchez has 40 canvases. And tubes of paint are how much? 100 tubes of paints. So again, she want to get a number to distribute such that each student could get an equal amount of canvases and equal amount of tubes. So we have to find the factors again for 40 and for 100. Starting from 2 again, 20, 10, 5. 2, 50, 25, 5. The factors of 40 are 40 canvases are. That is equal to 2, 2, 2, 5. And for F100, we get here 2, 2, 5, 5. 2 5s and 2 2s. 3 2s and 1 5. So the common are 1, 2, 3. There are 3 commons. So what we write here is 2 multiplied 2 multiplied 5. So what we come up with 2 to the 2 times 2 is 4, 4 times 5 is 20. My dear students, the answer comes as 20 and the 20, well, the unit for 20 is 20 students. So I don't know how many students does she have in her class, but she can distribute to the 20 students an equal number of 40 canvases and 100 tubes. Last question for this exercise is Indra has 300 blue beads, 700 red beads, 900 silver beads. So again we come to only to the if we focus only to these numbers. What Indra have is Indra has how many beads? 300 blue beads. 300 blue beads. And 750 red beads, and she also have the third color as well, and that are silver beads. So again what we do, we simply come to the working part of the question, and that is 300, 750 and 900. Starting from the lowest number 150 to 75, 3 and 5. 2 2 times 4, 4 3 times 12, 60, 65 times 300. And again for 2, 375. 3, 3 1 are 3, 3 2 are 3 5 are 5, 5 2 are 10, and 5 are 25, and 5, 5, 5, 5. Last for 900, 2 times 450, again for 2 times 225. No, this is not divisible by 2 now, but this is divisible by 3 because the unit it comes as 9. 2 plus 2 is 4, 4 plus 5 is 9, 3. So I have to divide it by 3. 3 7 times 3 7 times 21, 1 comes out and what left is 15, 75. Again for 3 times, 3 2s are 6, 3 5s are 15. And this is the outcome. So in the last, what we do here is we write the factors, all the factors over here. For 300, F 300, I write 2, 2, 3, 5, 5. 2 times 2, 4, 4 times 3, 12, 12 times 5, 60, and 60 times 5 is 300. Okay, it is also checked. 750. 3 5s, 1 2, 1 3, 3 5s. 2 times 3, 6, 6 times 5, 30, 30 times 5, 150, 150, 5 times 750, 900. 900. 2 times, 2 times, 3 times, 3 times, 5 times, 5 times. 2 2s are 4, 4 3s are 12, 3s are 36, 36 5s are 180, and 180 5 times is again 900. Okay, the question is completed. Now I have to find the common factors in between the 3, 1, 2, 3. Common factors are this row is common, this, and this is common, and 2 5s, 1 5 pair, this pair, and this pair. These are all common. So what I do is write them once. 2 multiplied 3 multiplied 5 multiplied 5. So what is the outcome? Final outcome is 2 multiplied 6. 2 multiplied 3 is 6. 6 multiplied 5 is 6 multiplied 5 is 30, and 30 multiplied by 5 is 150. So Miss Indra will have to follow 150 bracelets out of it. 150 bracelets as the question demands. So dear students, this is all for today. We'll meet in our next lecture, and that starts from prime number. It's time to say goodbye to you. Have a nice day. Allah Hafiz.